5.7 over 424. It says indefinite integral of e to the t over 1 plus e to the 2t dt. All right, so one thing a person might think about this problem could be use substitution. It certainly is use substitution, but there's a certain one you might think at first, perhaps. You might think that I should take the entire denominator to be u, and if we did that, let's just see what happens here before we proceed in the correct way. Let's go down a wrong path for a moment here. So u equals 1 plus e to the 2t. That's reasonable at first because you kind of start thinking that this derivative will come back, and I'll get this combined with this, which is correct to some degree, but the derivative is going to be e to the 2t times the derivative of the exponent, which is 2, and then dt. So the problem is not the 2. The 2 is easy to manipulate over to the other side, but it's the e to the 2t dt, which this is not. This is e to the t dt. They are not the same. So therefore, this substitution will not work in this instance, and we need to try something else. But something else is probably not so obvious at first, but once you see it, you'll be able to apply it in different situations, and it is to remove this doubled exponent, remove that doubling to the outside as a square. Okay. We know that, of course, e to the t squared, right, when you have an exponent raised to another exponent, you multiply the exponents together. So this is a legitimate extrapolation from this expression. Usually you're going the other way. Usually you try to combine these two into a more simpler expression. But here it's helpful to view it in this manner. And it kind of makes me think that u should be, now that I see a composition of sorts, u should be e to the t. The lack of composition being apparent here kind of leads me down a wrong path. And now that I see a composition in front of me, it turns out this will work out just fine. I will get e to the t dt here, which is exactly what my numerator is, e to the t dt, and that will be taken care of by du, and this will be u itself. So therefore, we should get the integral of 1 over 1 plus u squared du exactly, which is, of course, the tan inverse structure. So tan inverse of u plus c, but u was e to the t. So now we can write it back in the original variable t, get tan inverse of e to the t plus c. There's our antiderivative.